And we're live. So, welcome to this Gren development update. I'm Robin Hansen, the lead developer of Gren. And today I've got a special guest. Say hello, Justin.
Hi, Justin. I've just been playing with
Hey,
Gren,
I've got a
making a
special
couple things.
guest. Say, did I hear a bit of echo
You did, and I'm fixing it right now.
there?
Sorry about
All right. So, for those of you who do not know Justin, he is the author of the HTTP server API in the Grenlang node core package. So the fact that you can make HTTP servers with Gren is not my benefit, uh, at least not directly. That's all Justin. Um, all right, so we have a lot of ground to cover today. So I'm just gonna get started with the agenda here. Um, so the plan for today is that I'm going to present the new development roadmap for next year or so for the Gren language. Then I'm going to give a demo of the new HttpClient API for Gren. And after that, Justin is going to give a demo of the Prettynice web framework, which I'm quite excited to see. And then finally, I'm just going to round off with how you can contribute to Gren should you want to. And if there are any questions at the end, we can answer them there. Of course, if you have questions on the way, just write them down in the comment section, and we'll do our best to answer them as we move along. All right, so first of all, we have to talk about a new development roadmap. Now, Gren has Gren works by a 6-month release cadence. Essentially, I tried to make a release of Gren in June and a release in December. And if you paid particularly close attention, you would have noticed that there was no release this December. And the reason for that is that parametric modules, which was the cornerstone feature of that release, uh, it turned out that my strategy for implementing that wasn't good. I I essentially came to the end and found out that nope, this isn't going to work. Uh, and of course, without that feature, there wasn't really a point to do a release. Now, there are a couple of reasons why it didn't work out the way I'd hoped. Uh, but really, the essence of it is that I have a very limited amount of time to develop Gren. I have around a couple of hours each week. After having put the kids to sleep and made sure that the roof on our house is standing for the next day, and in the remaining hours I try to work on Gren as much as I can. But with those hours I work on a code base that I'm not overly familiar with. For those who do not know, Gren was forked from the Elm compiler, and the Elm compiler is a very, very big project, which is heavily optimized for compiling Elm code. And a lot of the time, I spend well, not a lot of the time, but there is a non-insignificant amount of time that I spend trying to figure out how the Elm compiler works as I'm implementing things. And of course, the second element of that is that the Elm compiler is written in a language that I'm not very good at. Part of that is, I guess, my own limitations, but also the fact that Haskell, which is the language in question, is actually quite complicated. um, and so there are other ways of implementing parametric modules um, for in the Gren compiler, um, but I spend a significant amount of time trying to figure out how the Elm compiler works and how Haskell the language works. And I also am trying, like, parametric modules is an advanced feature, and the Elm compiler was never really built to deliver that. And so I'm really just trying to bend code that wasn't meant to bend the way I'm trying to bend it. And I don't really think that I can keep doing this as Gren is diverging more and more from Elm. So I think I need a new way of developing Gren moving forward. Um, and that plan is called Gren in Gren. So hopefully, starting from about next week, I will begin work on rewriting the compiler in Gren. And the benefits of that is that I get to design a compiler for Gren from the ground up instead of taking the Elm compiler and trying to make it do the things that I want. Um, and Gren has tools to help me with that. Like Gren has a very decent step-by-step debugger stemming from the fact that Gren 03 has source maps enabled. So I can use the built-in debugger in Node.js to do step-by-step debugging of actual Gren code. And when I do rewrites, it can become a very, like, it's a very good opportunity to actually write unit tests. The Elm compiler doesn't have them. Uh, Gren can be built like that from the day one. Um, Another benefit of rewriting Gren in Gren is hopefully that it becomes easier for the community to contribute. It's the same language that you would use for anything else. Uh, it's, the compiler would just be yet another Gren program. And as a side benefit, the quality of Gren's core packages would improve just from the fact that I would actually be using them in real world code. So currently, I feel more of a Haskell developer than the Gren developer, right? My experience with Gren is purely designing APIs, but I rarely get the time to use them. Writing Gren as a Gren application would make me use the core library more, and it would make it easier for me to figure out what works and what doesn't, and find any bugs that might be hiding there. And finally, another benefit would be to have the Gren compiler as a package. So if you want to make a language server protocol client for Gren, you could just implement the compiler, or you can just import the compiler and do code analysis or code generation or code rewriting or whatever you want, right? If you want to do like linting or code generation for, I don't know, GraphQL or OpenAPI, you could just use the compiler to do that directly from Gren code, saving you a lot of time. Now, this really is a big rewrite. And the trick with big rewrites, or the problem with big rewrites, is that you might begin rewriting and never finishing it. Or at the very least, it may take a very long time. And so the plan to avoid having a rewrite that essentially pauses development for a couple of years is to do this incrementally and to do continuous releases, right? And the way, like, so I wouldn't begin rewriting the entire compiler. I would begin by rewriting the npm installer in Gren. And the npm installer is a single script. It's a JavaScript that stands between you and the Haskell binary. It accepts the arguments from the command line, downloads the Haskell binary if it isn't already in the system, and passes the arguments onto that. Once I've written that in Gren, we kind of like already have a layer that we can gradually expand to cover more and more of the compiler. So the step one would be to rewrite the npm installer, and then that could be one release. And in the next release, I could do all the command line argument parsing, uh, and then remove that from the Haskell binary, move it over to Gren code. And then that in maybe even in that same release, I could rewrite the package manager in Gren, and then the parser and the qualifier, etc. And of course, we want to be able to deliver new features as we're doing this. And so if we're rewriting the package manager, it would make sense to also look at how can we improve the package manager as part of this rewrite. And when we're rewriting the parser, it would make sense to figure out what sort of language features could we do as a parser thing. So the plan wouldn't be to rewrite all the steps and then add new features, but to do that continuously as we're rewriting the compiler. Um, the downsides of doing this will probably, like one of the tenets of Gren, just like Elm, is to have a fast compiler. And JavaScript, which Gren compiles to, is not as fast, at least not potentially, as Haskell. Uh, But the goal will still be to have a fast compiler, uh, and I'll try to make sure that that the compiler performance will be good as we're doing this. Although, at least temporarily, it might not be as good. Uh, but I'm confident we'll have a fast compiler. And of course, the second problem that I haven't listed here, but which is the problem all the same, is that um, I mean, doing this rewrites does mean it might take a little bit longer, maybe, but we've already reached a point where working with the Haskell code base is not very easy. Yeah. So that's what I had to say about the development roadmap. And the next step is to do a presentation of the HttpClient API. But if there's any questions about this section, then now might be a good time to, like, if anyone has questions to the development roadmap and the plan moving forward, I'm just going to wait a minute or two to see if any questions pop up about that.
I'm excited about. You said that the potential downside is things could take longer. I'm hoping that that's offset by it becomes easier to actually contribute and help.
So do I. I just I just don't want to get my hopes up just yet. But yeah, definitely it would, like, yeah. I mean, Gren already has good examples of features being implemented by people other than me, and the best examples are where things are being implemented as packages or as pure Gren code. I have the least amount of contributions to the Haskell compiler itself, which is understandable. All right, I can't see any questions. If you're currently formulating a question, that's fine. Justin will interrupt me, I'm sure. But I'm just going to move on to the HTTP client, which I'm hoping to release tomorrow if everything goes well. It's pretty much done. I'm just doing a couple of last minute error handling checks. Um, but the plan is to release tomorrow. So the first thing is I want to point out a few things in the documentation. Um, the HTTP client will be available in the Node package. The Node package is kind of like the an extension of the core library when you're targeting Node. So when you're developing Node applications, you will have access to an HTTP client starting tomorrow. Um, there are a couple of things I want to point out. Um, most modules that perform side effects in a Node package requires that you first obtain a permission. And that's not to prevent you from using it, but it's the idea behind the permission system is that if you pass if you, like if you're calling a third party package, like if you're using third party code, the fact that certain things are gated behind permissions mean that you can trust that the code only does what you give it permission to. So if you don't hand off a permission to a third party library to perform HTTP calls, then you can be quite certain that no HTTP calls would be made as part of calling that function, even if it returns command, right? Now, most modules in the Node package at the moment only works with like a pretty broad permission. Like either you can make file system operations or you can't. There isn't like you can't give permission to only do stuff within a directory, for instance. So the HTTP client API is the first module that allows you to only give permission for a certain host. Like, I want this module to be able to make side effects that involves making an HTTP request, but I only wanted to make HTTP requests to Facebook. So you can actually do that. You can limit it to a specific host. And then If you want to make an HTTP call, you have to create a request configuration, which is a record, which you can customize using, with header, with a string body, and you can expect to retrieve JSON as a result of that HTTP request. Once you've built a request configuration, there are two ways that you can actually make an HTTP request. You can do the simple thing, which is to perform a send, and that will return a task that might fail or it might result in a response. Now, this task-based approach is, that's the simple way of doing things, and it will return the entire response in one, like it will return the entire response at once. The alternative to that is to perform a streaming request. So you would call stream with the request configuration, and then you would need to pass in a function that um, sends a message to your application's update function. Um, and then your application would have to deal with certain events. So you would get a message every time a piece of data has been sent to the server. You would get a message every time you've received data from the server. And if you abort the operation, or if you get an error, or when there's nothing more to receive, those will be messages as well. And the idea behind streaming requests is that you can show a progress update to the user as you're downloading, especially when downloading big files, right? Or you could um, download a huge file from S3 with one HTTP client, and then you can upload it simultaneously to another service with yet another HTTP client without storing the entire file in memory in order to do so. Like you can just, if you receive 60 kilobytes of data from S3, you can send those 60 bytes immediately with another HTTP client. So, and um, and the HTTP client is the first API to have like a streaming API. So the idea here is that we'll see how this streaming stuff works out. And if it works out well, this might arrive for the file system API and the child process API, but this is where we're trying it out first. So that's like a broad overview of how it works. Let's try to see some code. So here is a simple example. This is a full Node program. And by Node program, I'm meaning here's a Gren application that you can run using Node. Um, this is a simple program, which means it's a program that only does one thing and then it exits. So as the program is initializing, we're going to obtain a HTTP permission to VG.no, which is the largest newspaper in Norway. And once you have that permission, we are going to create a request that retrieves um, the front page of VG.no. Since you can only perform operations against VG, the URL here will be relative to the host that you have permission for. We are going to expect the return value to be a string, and we are not going to handle errors. Or, well, if we get an error, we will just convert it to a string and display that. And once that HTTP request is done, we're going to print the result to standard out. All right, so I'm going to compile this, right? And that results in a file, which I can, that results in an executable that I can call. And here is the HTML for the front page of VG.no. So that was the simple, that was like the simplest HTTP client example that I could show. But then we also have a streaming API, which is more complicated because we need to handle events as the request is in progress. So here we create like a full node program, which requires us to define an init function and an update function. And as the system is initializing, we're going to get uh, a wild HTTP permission. Like this is an HTTP permission that allows us to do whatever we want to any kind of service, which is why we define the entire path um, here in the and when we're building the request object. We're gonna expect data to be returned as bytes. And that's simply because when we're streaming the response, we might get um, like if we were to expect JSON, we wouldn't get pieces of JSON incrementally. We would just get a couple bytes here and a couple bytes there. So we can't really expect to receive coherent data every time. But anyway, we're going to perform a streaming request, which means that we're going to get messages as the request is progressing. So in the beginning, the first message we're going to receive is a message from the Gren runtime that our initial data, or you know, the first chunk of data that we wanted to send has been sent. Now, if we were to send, like we could start, in theory, we could start by sending 20 kilobytes of data. And once we receive this message, we could generate another 20 kilobytes of data and send that. We don't have anything more to send. So once we know that we have sent the first piece of data, I guess we are not sending anything at all, actually. So this will just happen immediately. And then we're going to call this start receive function, which essentially lets the HTTP client know that we are done sending stuff and we're ready to receive stuff from the server. And then we're going to get a message for every piece of data that we receive. And we're not, like in this example program, we're not going to do anything special, anything specific with it. We're just going to print to the command line that, hey, I received X amounts of bytes. And that's it. And if there are any errors, we're going to print that to the terminal. If the request is aborted, which it won't be because we're not calling HTTP client.abort anywhere, but if it were to be aborted, we print that. And once there are no more data to be received, we're going to print streaming done. So this is like we're not doing anything useful with this at all. We're simply just reporting the events that take place when we're performing an HTTP call. All right, so we're going to do the same thing. We're going to run. And here you can see that we're downloading the exact same thing as in the previous example, but you can see that we're actually receiving it in a lot of chunks of just a little over 1 kilobyte at a time. Sometimes less, but most of the time we're receiving 1.4 kilobytes. Um, and we're doing that a lot until we're done. So in theory, since we're retrieving HTML, you could retrieve, like once you receive 1.4 kilobytes, you could parse that into HTML and then wait and then parse the next and then parse the next, and essentially doing this incrementally parsing. And in measured in wall clock time, this would be more efficient than waiting until you received all of it and then do the parsing thing. Or we could just do a progress bar sort of thing, and then once we have all the pieces, print that just as we did in the previous example. All right, so yeah, that's the HTTP client API. I'm hoping to have that available tomorrow, and yeah, I'll just pause for a minute, see if any questions pops up. before
I
allowing
had a couple.
Justin to show off his thing. Yeah.
Is there any way to have, when you're getting a permission, is there any way to have a whitelist of hosts, or have you thought of that, or is it just all or nothing? I mean, all or one.
It's just it's currently it's just all or one, but there is no. Yeah, I just haven't thought about it. But I could add like a whitelist. That's a good idea.
My other question is, I think I've already asked you this, but I don't know if you want to share your thoughts on it. Why you didn't go down the route of subscriptions for HTTP streaming?
Yeah. Uh, I mean, HTTP streams is something that has a specific life cycle, right? When once the response has been received, it's done. And when you have a subscription, you kind of encourage this. You have to tell the runtime to like what am I listening to, sort of. And I don't know, it just felt strange. I guess. Like if you're making a request, it makes sense that you're going to be listening to that request for as long as it lives, and then you're done. It would be strange to. Well, I guess it would be also more work if you first need to start a HTTP request and then have a subscription for that HTTP request, and then removing that subscription once the request is done. But then if you remove that subscription before the request is done, does that mean you want to cancel that request? Or so in the end, it just seemed more natural to me to just say that I'm making a request, tell me about every single event that comes in, and then you can kind of like signal that you're not interested in anything else, or you can abort the request, at which point you won't receive any more messages. I'm not sure I answered your question. But
I think you did. I ultimately really like it. I like that. It's very straightforward and uniform. Everything's in one place.
Yeah. All right, so I
And
can't see any more questions, so I'll just hand it off to Justin to show off his
all
pretty
right.
nice web framework.
I hope it's pretty nice. I need to move some windows around, and then I'll share my screen here. Oh boy, I can't remember which monitor number I'm trying to share here. Here we go. Fingers crossed. You should be looking at my terminal if I shared the right one.
I am looking at your terminal.
All right. Okay, so my demo doesn't really have slides. I was just basically going to show what it's like to use the Prettynice framework. It's a full stack framework. So HTTP requests go straight to the server, and the server sends you a response. That response can be HTML, text, JSON, whatever, bytes. It does support client-side components like a browser.element type model view update client-side interaction thing, but not as like a single page application. It's not handling routing or anything like that. It's just a little, other frameworks call it islands. So it's a little island of interactivity, but I'll get to all that. Just starting fresh with an empty directory. Since there's an npm package published alongside the Gren package, and it's also called Prettynice. npx will download it if you don't have it already, and the command to create a new Prettynice project in the current directory is init. And what that will do is it will give you a example to start with. So it'll be just a simple server-side router and one client-side component, which I'll get to in a second, but let me just make sure everything's working. It also sets up Nodemon as a development server, so you can have it automatically restart when you make changes, things like that. You can also see it's actually building two Gren applications. So all of your client-side components will be bundled into a main.js, and everything on the server side will be bundled into a server main.js. Okay. There it is. Amazing. So what that looks like in code. So this was the, let's actually go into the directory. This was the two bundles I was talking about. So all of your client app is here, and your server app is separate. It doesn't, there's no magic behind the scenes that, you know, pulls certain bits of code out and creates the two bundles separately. It's very explicit. You know, everything that's going to that's going to happen client side is going to be here. Everything that happens server side is going to be here. Excuse me. I've been talking all day, so my mouth keeps getting dry. I apologize. The public directory also, anything that's in here will be available at the root path. So if you had other JavaScript you wanted to use, images, style sheets, anything like that, you just drop it in public and you can reference it at the root URL path. So I will let's start on the client side and look at the counter component, because this is pretty straightforward. It's what you're used to. This is essentially a browser.element, but it's a little bit different because it has something called props instead of flags. So there's your model, which is pretty normal. But these props work just like flags, except you don't pass them in browser side through JavaScript. You pass them in server side through Gren. And Prettynice will make sure that the type signatures are set up correctly, and it automatically sets up the encoders. So you basically are going to initialize this component server side the same way you'd initialize anything that takes props as an argument. Okay, let me look through here and see what we did. Let's go look at the server side of things. It's just a normal main.gren on the server side. But you have this, it's define program and start program similar to a Node app, but you're gonna split it up into an init and a router. The init just says what your host and your port is. You can pass those in via the args if you want to. What happens if a record element in props defines a function? Is it possible? So that's one of the limitations, is right now there's only very specific types that will work in as props. So it expects that it's a record and expects that the record contains only basic field types. I'll go over those soon, but it's you know, int, string, bool, maybe, array, that kind of stuff. So you can't have a custom type. I'm hoping that some of the changes that Robin is talking about down the road, especially after Gren and Gren, will help make that easier. So it'll expand the type of props you have. If you do use something though that's not supported, it'll fail at compile time. Like, you won't have a runtime error. It just won't compile, and it'll say, "Hey, I couldn't understand your props. Here's how they should look." In fact, I can show you that soon. But the routing is just going to be, there's nothing built in really for routing. It just adds a little bit to the response type. So these are very similar to the low level Node HTTP request and response objects, but they have some niceties, like there's a path field which splits the path on / into an array, so you can use pattern matching. But you can also match on the HTTP method. You can match on the headers, anything. Here I'm just sending HTML back, and this is again the same, just extra helpers on top of the base response modules. So send HTML just make sure that the content type header is set appropriately, and it handles all the whatever you need to do to get your components rendering properly, all of that. Which is why it's split up into, you know, if you need anything extra in the head, you can pass that. here I'm linking to a style sheet. And then the body is just an array of HTML. And this is going to be server-side HTML, which is I'll get to. But I'm going to have to look at my gren.json to remember the right names, because I always get confused who wrote what. But I'll cover that soon. But the other people have contributed stuff that has made this much, much easier to write. And server-side HTML was a really big one. Speaking of server-side HTML, this is what that looks like. Here's the component that I showed you earlier. You're not literally importing the component that you wrote. The build step creates this gen.components, and it's going to end up in so yeah, I'm gonna show hidden folder. So it's in here, and that's just handling the encoding. It's writing the JavaScript that needs to get spit out, but that's all generated for you.
May I ask how you are generating that code? Are you essentially using string templates and doing string replacing and stuff?
Yes.
Yeah.
It's actually, let me. So a lot of this is, again, forgetting names. I think it was Steven, has a package called Shikenzu, and it's able to take a list of files or directory and perform a bunch of actions on them and spit them out. So I was able to use that to help out a lot. One downside, though, is it did couple me to POSIX paths. So right now, this doesn't work great on Windows. That's high on my list to fix, though. But yeah, for example, I'm doing string replacement. It's not ideal, but
right.
Maybe stuff like that in Gren.
Are you able to do all the things you want to do with that, or is there, are you limited?
I'm able to do all the things I want. I think where I said it's not ideal is you don't get the normal benefits you would if you were writing normal code in your editor.
Right.
So let me get back to my script here because I went a little off. Oh yeah, so here's, you can see we're passing in the props here, and those are gonna align with the props you defined here. They show up in the init function, and of course it's all type checked. If I try to pass something that's not right, the compiler fails with a nice normal Gren compiler error message, same as if you weren't crossing the server browser boundary. So normally this would happen in the browser, right? You'd have JavaScript that passes the wrong data type, and you have an encoder, and you have the runtime error check that shows the error page. This is one of the main reasons I wanted this, was I wanted all that to happen before I even ship the code. This is, if the data types aren't right, it's going to fail. It won't even compile. So something else that's nice too is that these are all independent. So I can make another version of this. I made another counter, and that one starts at 1, 2, 3. And that should, yep, that all compiled. Now I have 2, and they're independent of each other. And looking at the HTML, there's the server-side HTML comes through as HTML. So it's not JavaScript, but the component is coming through as JavaScript. It's basically, you can kind of imagine a new type of HTML function that returns JavaScript and not the HTML, just a string of JavaScript instead of the string of HTML. That's essentially what this function is doing. So you can treat it as HTML. What it spits out is a string of HTML that's actually a script tag. And again, the style sheet is just something that was in the public folder, so I'm able to reference it at the. I should close, not have all my windows open here. Able to reference it at the root path. Oh, something I wanted to show in that HTML2 was the encoding. So if I was going to, an int isn't the most helpful thing to show off encoding. So I will just show something else like, well, first let me show what I was talking about before, where like if I have an unsupported type, can't do that. Prettynice tells me I can't do that, and it links to the types that are supported. I'm linking to. I need to fix this. I was linking to the GitHub URL because at the time the package wasn't published yet. I would have just published the package, but you can see these are the types that are supported. Ints, floats, strings, bools, arrays, and maybes. That's it for now. High on my list to expand that list. But if I was going to do something like, let's say, an array of maybe bools. Well, right off the bat, the compiler is going to complain because I added a field to my props, but I'm not passing them in server side. So I need to fix that. Compiler should be happy now. You can see, zoom in a little bit, but all the encoding would happen for me. I didn't have to write any encoders. I didn't have to write runtime error checking. It's just if it compiles, it's going to work. Okay. Looking at my script again, I apologize. All right, I was going to go through some of the examples in the repo because they cover some more of the features here. So if you're on GitHub, it's Blake/Prettynice. In the examples, I tried to cover, this is pretty much everything I needed from the MVP of this framework, because a big driver of this for me was a personal project that I've been trying to get off the ground for a while, and I've done it many different times in React, and Remix was nice. That's a good server-side framework. Lambda, I tried an Elm and Rust combination, which I think got the closest, but then when Gren hit my radar, I was waiting for that node support. And then after the node support, I was waiting for that HTTP server support. But then I got tired of waiting, which is why I added it myself. Robin was super, super helpful for that. Just answered all my questions. I was coming in pretty blind, never having done anything that had, purely functional effect systems or anything like that. So he was a lot of help. I'll highly recommend if you want to contribute anything to Gren, hit the Zulip that's linked on the Grenlang website, and everyone is super helpful, especially Robin. The examples. So I'm gonna just jump into them. They're all working examples. One example I wanted to show was the client-side components example because it's an example of having multiple different types of components. So before I just had counter, but it's going to look at all your components and build them into one client-side bundle. And they all, again, work nice and independently. That's.
I think you still have your previous demo running.
Yeah. So there we go. I need to add a check for that.
The I believe you've told me this before, but the CLI, the Prettynice CLI tool, is that also written in Gren?
Yes, it is. Uh, that was really fun to do, and it's all in the same repo. If you're curious, want to see an example node app, Prettynice repo CLI. It's just what Robin was showing. I'm initializing some subsystems, getting permissions because I need to do this file system. I need to call child processes. That was all really nice. I don't think I've ever written a CLI that I felt so comfortable working with.
Good.
And again, people have contributed packages that have helped with this. The args package is great. So yeah, any .gren file in the components directory, and you can nest them too. That'll work. It's basically just writing a browser.element. You just have props instead of flags, and you use this type signature. If you don't do that, the compiler will yell at you and say, I can't compile this. I don't know what to do with it. But then you just, you can refer to any other browser target compatible Gren that you would normally. I wanted to talk about ports because the framework has some helpers for that. Let me just make sure I don't have anything else running. Okay. So if you put a ports.js file in the server directory, it will automatically include that server side. And if you export an init function, it'll hand you the app object that is your compiled server object, which means you can have ports. So here I'm just using it as an example to get a UUID. Server side ports. And so that's just grabbing a UUID from the node side. And in the Gren side, it's pretty much the same type of program, except it's a port module instead of a normal module. The other thing is that it's not using the router. So a router is like the simple program version of a node app. So if you're just responding to requests, not doing anything complicated, you don't need to send commands or anything like that. You can use that, but then you can bump up to a full program, which has the full init, update, subscriptions, just like a normal Gren program, with the addition of this on request message. And all that is it's just going to trigger in your update a message that says, you got an HTTP request. How do you respond to that? And here's where I'm responding to the message from my port. That was server side ports. Client side ports are a little bit different. So on the client side, your Gren module, like I said, is this component. But if you put a JS file with the same name as your component, you can tie ports to it that way. You can also just have arbitrary JavaScript in here. But similarly, you export an init function, you get your component object, and you can subscribe and send port messages, and they'll show up just like a normal JavaScript client-side port would. I'm just making sure that nested components work here, and they do. One more example I think I want to show. I was hoping to have a better example of this, but database interaction, not technically possible, not possible directly through Gren. But with ports, it's pretty straightforward. So why don't I have anything here? Okay. Oh, because I was in the wrong directory. So in my JavaScript, I just use Prisma. If you're familiar with Prisma, it's just a ORM for JavaScript. And I'm querying a users table that I set up with SQLite and passing those in via ports. So here I got my users through the port, update the model, and show it off. The init function that generates your project gives you these npm commands, but they're just calling Prettynice. So there's a build command. You can pass it optimize if you're building for production. And then to start your server, you just start the Node app that's in the dist folder. So dist will have a server folder and a client folder. But the server knows the location of the client folder, so it knows how to serve that stuff. Here's my list of users. And that's coming from just a SQLite database. I don't know if I have SQLite 3 installed here yet. No, I'm not going to show that. It's a database. I was hoping to show using SQLite over HTTP using the new HTTP client that Robin wrote, but I waited until two last minute to get that working, and I wasn't able to get it working. So the last thing, I think, I'm just seeing if I missed anything. Oh yeah, I wanted to talk about the packages that this depends on. So I think it's Steven, cannot remember his last name, wrote the HTML Gren package, which was one of the first things that like my eyes lit up and I saw lots and lots of possibilities. And there's still a lot that I want to do with this. But this is what lets server-side HTML happen. And it works both ways. You can there's a virtual DOM package so that you can have the same code, but you can either spit it out as a string server-side, or you can have it converted to virtual DOM client-side. And that's what Prettynice is doing. The Joey wrote the static serve package, which saved me a ton of time because serving CSS, serving images, things like that, I didn't have to write all the code to, read the file system, make sure that those were there, serve it if they exist. Just install this package and it worked. It's fantastic. Also in the CLI, that's a different. I talked about, this is also Steven's package, the Shikenzu program. The CLI is basically just one big file transformation script using the Shikenzu packages. I don't know if I'm saying that right. I mentioned Joey's package, Gren args, makes arg parsing really, really easy. It handles, the short versus long arguments that have values and don't have values. That was great. And the I can talk about deployment, but it's basically just you just serve that dist folder that gets created here. So for example, if you're going to host on fly.io, I mean, all you have to do is do the normal fly CTL launch. It recognizes that you have a Node app. It makes a Docker file that works out of the box, and you just fly CTL deploy, and it will work. Happy to do that if I see somebody say they want me to do that. But let me go back to the demo folder because I'm about in wrap up mode. I did have a couple slides. So yeah, like I said, the repo's at GitHub Blake/Prettynice. If you search the Gren package site for Prettynice, you'll find the API docs. And like I said, this is basically the web framework that I've wanted for years. This is normal multi-page app style request response cycles. The client-side components are all standalone. There's not this deep nesting and routing and everything that you need to deal with. Everything you need, the biggest driver for me for this is that everything you need to serve a page, including everything that it needs to be interactive, is included in that initial page load. I hated constantly writing things where I would ship HTML and then that HTML would make a request back to the server to get data, and then I'd have to handle if that data was right or not. As opposed to, it's all already on the server. Most of the things that I write are like that. So whether or not it has client-side interaction, I should be able to ship it all in that response, and that's what's happening here. And as a result of that, all that stuff can be type checked at compile time instead of runtime. But there's other frameworks that do this, but not with what I really wanted. And it might be taboo to mention Elm, I don't know, but I get all of this with everything I love from Elm, which is the purity, the immutability. I'm imagining everyone who's watching is in the same boat. No runtime errors. The static type system is amazing, and then the Elm architecture, the model view update baked right into the language is fantastic. Some stuff that's on my mind coming up. These are things I either am already working on, will be working on, or thinking about working on. My to-do list changes multiple times a day. If you look at the commit history for Prettynice, at least half the commits are probably updated to do. But the very next thing, I'm currently working on this, and I really wanted to have it ready for the demo, and I didn't, but is a doc site, because I don't want to rely just on the repo README and the API docs. I really want a proper documentation site that walks you through setting it up, how everything works. After that, I want to fix the dependence on PostFix paths and get Windows support. And at that point, I will be migrating my personal project that I mentioned earlier, which has failed to fully get off the ground for a while, just because I haven't had exactly what I wanted. And I think I've got exactly what I wanted now. And then I can start adding some niceties to this, like cookies and sessions. You can technically do that now because you can set whatever headers you want. You can read whatever headers you want. But having a nice API around that stuff is very helpful, including similarly asset bundling, post-processing, your CSS, JavaScript, that kind of stuff. Everything you're doing with ports and Gren, that's all handled by the compiler. But if you want to do anything outside of the Gren ecosystem, you just have to do it yourself. Add the proper stuff to your package.json, drop the files that are compiled into the public directory, and you'll be able to serve them just fine. But I like the batteries included style of framework. So that's the direction that this is going to go. And another thing I've wanted to do better, that it really, really bothered me that I couldn't come up with a good way to have an API that helps with nested T. If you're not familiar with that, it's, as soon as you build something in Elm or you build a SPA with Gren, you have to start thinking about, how do I have everything not be in one giant file? I want my pages to be in their own module. And to do that, you have to start nesting your messages and mapping your commands. Again, you can still do that. I have an example in the repo that does that. But one of these days, I hope the light bulb clicks on and I figure out a way to have the framework help with that. Similar to how Elm Pages and Elm Land do that for you. I did start going down that road, and I looked at their code. It's just a little bit too much code gen for my taste to the way that worked, and I feel like there's a better way with the server side nature of this that can make that work. And like I said several times, supporting more types in the props. That's another, I think, sore spot is it's very limited what you can pass in, just raw data. You can't have a nice custom type to define your things. Okay. Any Is there any questions or anything else? Because I am at the end of my demo here.
Well, while we're waiting for while we're giving people time to write questions if they have them, I just want to say that like I'm amazed at what you've been able to do. Like I remember like one of my motivations for making Gren is really the exact sort of stuff you're doing right now. And so I was like, when you said you were working on a Prettynice web framework, I was like, ah, oh, great. Someone is doing well. Actually, I felt sort of robbed that I wouldn't be able to do it myself. But you've really been able to make something cool here, and it's great to see that you're like I said earlier. I feel more like a Haskell developer with some ideas about language design. I don't get to write Gren as often as I'd like to. But it seems like creating CLI tools, creating a web framework, it's great to see that you can actually make stuff with Gren at this point in time. And
Yeah.
it's also pretty impressive what you're able to do with it.
Oh, thank you, thank you. Yeah, your help was a big contributor to that, and like I said, the other folks, Stephen and Joey, especially, who've contributed packages, were a huge help as well. I'd probably still be working on it if they hadn't shipped their packages. I mean, I'm still working on it, but I probably wouldn't have anything published.
Yeah.
Oh yeah, there was one glaring hole, and this is going to be a breaking change, so it'll probably bump from version 1 to 2. Was the version of the server that uses is not just a simple router. It actually uses init update subscriptions. Um, you can't send a command from init, which is most node programs. You can do that. You can do that with a browser.element. Um, it was just something I missed. It was very, very easy to add it, but it is a breaking change, so I haven't shipped that yet. Uh, might include some other stuff since it is going to be a 2.0 version. Cool.
All right.
I think
I
we're good.
can't see any other questions. So I think we'll just round off here. Thank you for giving that demo, Justin.
Thanks for having me.
And thanks to all of you for watching, all 5 of you.
I see 7.
UC7. All right, that's. But if history repeats itself, there will be a lot more watching it, and yeah.
Cool.
So like we mentioned, Justin here contributed the HTTP Server API. Gren is always open for more stuff. We're currently limited by people. So if you'd love to see an API in Gren, I don't know, WebSockets, IndexedDB, I'm definitely open for more contributions. So if you'd like to help out, reach out in the Sulip, and we'll take it from there. All right, that's it for now.